Hey Unite, welcome back to McGrathematics, the fastest growing maths YouTube channel in my entire house. We're starting off today's lesson with a few warm-up riddles to get your brain working, so here they are. First one, a one-story house has red walls, blue carpets, yellow furniture, and green windows. So what color are the stairs? Riddle number two, you're in a running race and you just overtook the person in second place. So what place are you now in? And the last one, a man has two coins that add up to 70 cents, but one of them isn't a 20-cent coin. What are the two coins? And we're assuming that they are both Australian coins. If you think you know the answer to any of these riddles, let me hear them in the comments down below. Okay, to start us off with the lesson, we are going to do some flashback questions of factorizing techniques we have already covered in this topic. So pause the video for me and see if you can factorize these three expressions for me. Okay, hopefully you did that because now I'm going to spoil it for you. For the first one, whenever we see a factorizing question with four terms, we're thinking to ourselves it's probably going to be one of those grouping pairs factorization questions. Because there is no common element in all four terms, we can't factorize all four at once. So we're going to factorize the front two and the back two, and then hopefully we can factorize them together. So in the front, we have a common factor of 4, and in the back two, we have a common factor of c. So if we factor those out, in both brackets, we end up with a take away 3b, which is great news because now we can factor the a take away 3b out the front of the expression and leaves us with a minus 3b out the front of 4 plus c. So that in red is our final answer, fully factorized. For question B, we have a difference of two squares. At the front, we have 15x being squared, and here we have 2mn being squared. So we can factorize as 15x take away 2mn, and 15x plus 2mn. Now, question C is the challenging one. It's a trinomial. It's a quadratic trinomial. We have a 4 out the front of the x squared, but we don't have a common factor of 4 in all three terms to factor out. So we've got to do our method where we multiply the minus 3 on the end with the 4 at the front, which turns us into a minus 12. Now we set up our two brackets on top of a fraction where we have 4x, 4x, and 4 because we had 4x squared at the front. Now to fill in the brackets, we need two numbers that are going to add to give 11, which multiply to make minus 12. So the numbers that are going to work for this one are going to be plus 12 and minus 1. So we'll fill them in. Now in the front bracket, 4x plus 12, we have a common factor of 4 that we can pull out the front to have 4 outside of x plus 3. The two 4s are going to cancel out and leave us with x plus 3, 4x minus 1. Awesome work if you got these three by yourself before I ruin it for you. Okay, for today's lesson, we are going to combine all of our factorization techniques we've already studied in this course, in this topic. And we're going to be looking at questions that involve multiple types of factorization to get to the final answer. So I think this is a really fun lesson. It's a bit challenging at first, but I think you guys will really enjoy it. Let's have a look at what we're working with today. Okay, before we do a few examples, let's just do a quick overview of the factorizing techniques we've already explored in this topic. So kind of things we're looking for today is, first and foremost, when we're asked to factorize, we should first check if there are any common factors that we can take out the front of the expression. Taking out a common factor is always going to make the question easy to handle, so it's the first thing we look for. Questions with two terms, if they have a minus, quite often the questions will be designed so they are a difference of two squares, so we'll look for that. Factorizing expressions that have three terms, often these are designed so that they are trinomials, like we've done a couple lessons on. So if we're looking for three terms, we'll see if it's a trinomial because we are good at factorizing those using our shortcuts. And for questions with four terms, quite often, like we saw in the flashback, they are designed to be grouping pairs factorization questions. So we'll approach them like that if we can. Okay, let's have a go at our first example. If you're feeling confident, you're more than welcome to pause the video and try it yourself first. Starting one's not super hard. But the first thing we're going to do is we're going to look for a common factor. Is there anything in common to both terms that we can factor out the front? Well, we have a common factor of 4 in both 4 and 36. We also have a common factor of a. So we're going to start off by taking out 4a out the front of our expression, leaving us with a squared take away 9. Now that's got us 1 mark, but there's some more work to be done here because a squared take away 9 can be further factorized as a difference of two squares. So a squared minus 9, we can go ahead and write that as a minus 3 and a plus 3. And then we have fully factorized the expression. So two things combined into one. Double the fun. Okay, for our next one, we've got 3y cubed plus 27y squared plus 60y. Once again, let's start by seeing if there are any common factors. Well, straight away we can see y cubed, y squared, and y. There's a common factor of y. So if we wanted, we could factor a y out the front of the entire thing. Now, the 3 in front of the y squared usually makes these questions pretty tricky until you recognize that you've got a factor of 3 in all three of these numbers. So as well as factoring out the y, we can also factor out a 3 out the front. So we have 3y outside of y squared plus 9y plus 20. And you don't have to do that in 2 steps. If you could see straight away that there was a 3y common factor, you can pull that out in one go, so you don't have to write 2 lines of working. Okay, now we're left with this line here, and what's inside is a quadratic trinomial, and so we factorize these, as we've done a few times. We're going to try and find 2 numbers that add to give 9, that are going to multiply to give 20. So for this one, the numbers that are going to work are going to be 5 and 4, both positive. So we have 3y outside of y plus 4, y plus 5, and now we're fully factorized. Let's try another one. We've got y cubed plus 5y squared, take away 4y minus 20. Okay, any common factors? No, there isn't. But like I said, when we have an expression with 4 terms, quite often these questions are going to be the grouping in pairs questions. So we're going to factorize the front 2 terms, and then we're going to factorize the back 2 terms and see if there's anything else we can do. So for the front 2, we have a common factor of y squared, and for the back 2, we have a common factor of minus 4. So we'll factor y squared out and we'll get y plus 5. If we factor minus 4 out, we get the same thing, y plus 5, which is very convenient. If we'd only taken the 4 out, we'd get minus y and minus 5, and that wouldn't work out. So we've got to take the negative out the front. Now we can factor the y plus 5 out of both terms, and we'll write that at the front. So we have y plus 5 out the front of y squared take away 4. Now, once again, the y squared plus 4 can go a little step further because that, once again, is another difference of 2 squares. That's y squared and 2 squared. So we'll write y minus 2, y plus 2, and now we have 3 brackets, and we are fully factorized. Okay, one last worked example, a bit of a tricky one. We've got 12 plus 8g take away 4g squared. Okay, now this is a trinomial because we have a squared term, a non-squared term, and a constant. It's a bit of an annoying one though because it's kind of written in the wrong order. So what I'm going to do first is I'm going to rewrite it. I'm going to have the negative 4g squared at the front. I'm going to have 8g and then plus 12 on the end. Now we have a common factor of 4, but when the leading term of your trinomial is negative, it makes the factorization really, really challenging. So when we have a question like this, what I'll recommend is factoring out the negative. So we're going to factor 4 out of all the numbers, which is not too hard. We're also going to take the negative out. So taking negative out of 4g squared is right here. Now, if we factor a negative out of a positive number, it's going to leave us with a negative number, which seems kind of strange at first until you think about, well, what if we expanded this expression here? Minus 4 times g squared is right there. If we did minus 4 times minus 2g, we would get positive 8g. So we're just applying that logic backwards. So factoring a negative out of a positive is going to give you a negative, because if you turned it around and multiplied, as we know from year 7 and 8, multiplying 2 negatives gets us a positive. Okay, so here is our expression with negative 4 factored out the front. Now we're going to have a look at this trinomial, and we're going to say, can we think of 2 numbers that are going to add to give negative 2 and multiply to give negative 3? Well, yeah, minus 3 and positive 1 are going to work. So we'll have g minus 3 and g plus 1 with a minus 4 out the front, and there we are fully factorized. All right, if you're getting the hang of this, you can pause the video now and have a go at these 4 questions for me, fully factorizing. D is a bit of a challenge, but I reckon you can handle it. Pause the video, see how you go. I'm going to spoil it in about 5 seconds. Okay, for the first one, we can start off by factoring out a common factor of 3. And then we're left with a difference of 2 squares. And so we'll factorize it as 3 outside of a minus 3, a plus 3. For question B, we have a 2 in front of the x squared, but luckily all 3 terms have a common factor of 2, so we can factor it out the front. And now 2 numbers that add to give negative 12 and multiply to make positive 36. That's going to be negative 6 and negative 6. That's a perfectly fine answer, or if you want to be a bit fancy, you can write 3 outside of x minus 6 all squared, because we've got two brackets multiplying together and they're the same thing. Okay, question C, we've got two terms and we've got a minus, so we're thinking, could it be a difference of two squares? 45 and 20 aren't square numbers, but they have a common factor of 5. We also have a common factor of AB. So we're going to factor 5AB out the front, leaving us with 9, take away 4a squared b squared. This inside the bracket here is a difference of two squares, so we can factorize as 3 minus 2ab and 3 plus 2ab, fully factorized. And now question D, we've got 4 terms, so we're thinking this could be a grouping in pairs question, so let's have a go. We'll factor b squared out of these front 2 terms, and we'll probably factor a negative 1 out of these 2. Okay, the reason I knew to factor negative 1 out of the back end is because I wanted these 2 brackets to match up, so I needed to have b plus 1 inside the bracket, so I factored the minus 1 out of both of them. Now, if we factor b plus 1 out the front, keep in mind that in front of this second bracket is an invisible negative 1. So if we factor b plus 1 out the front, we'll have b plus 1 outside of b squared take away 1, which is great news because b squared take away 1 is a difference of squares, and so we can factorize it as b minus 1, b plus 1, and we can be extra fancy by putting these two b plus 1 brackets together by using a power of 2. So that second last line would be getting you full marks in an assessment question, but the last line is probably a good habit to get used to, the idea of 2 brackets multiplying being a squared. Okay, we're going to finish off with one more challenge question. This is more of a year 10, maybe year 11 or 12 level question. We are factorizing x to the power of 4 plus 6x squared take away 40. If you're feeling confident or brave, you're welcome to pause the video and see if you can figure it out before I run you through the solution. Okay, so for this challenge question, it kind of looks like a quadratic trinomial because we're used to having something squared plus just the something and then a constant on the end. So it does kind of meet that pattern, except the thing that's being squared on the front here is already something squared. We can sort of see that a bit better if we do what's called a substitution. This is something we'll be doing a lot of in year 11 and 12 to make complicated questions a lot less complicated. So we're going to let x squared be equal to another letter, which we're just going to use u for today. Okay, so we're going to change this to x squared. We're instead going to write it as a u, which means if we took both of these and we squared them, we would get u squared is x squared squared, which is x to the 4. Okay, so by making this substitution, this x squared we're going to change to a u, and this x to the 4 we're going to change to a u squared. The reason we've done this is because now it is a quadratic trinomial, and now it's a bit less scary to factorize. So to factorize, we need 2 numbers that are going to add to give 6 and are going to multiply to give minus 40. So our magic numbers are plus 10 and minus 4. So we have u plus 10 and u minus 4. Now that we're factorized, we're going to resubstitute the fact that, well, this placeholder of u, it's actually meaning an x squared. So we're going to change this u and this u back to an x squared because the original question was factorize this, not factorize this. So now we have x squared plus 10 and x squared take away 4. Now the reason that's really good is because for the 5th or 6th time today, in our answer, we have another level of factorization because we have an extra difference of 2 squares. So this x squared minus 4 can be further factorized as x minus 2x plus 2. X squared plus 10 we can't do anything else with unless you want to do extension 2 maths in a few years. So for now, that is our fully correct, fully factorized answer. So once again, letting u equal x squared, so u squared equals x to the 4, turning it into a trinomial, factorizing, resubstituting what we started with, and then finishing it off. If you got that without me, you're a full-blown genius, and I'm really proud of you. Okay, here are your practice questions for today. Here are 25 exercise questions that involve multiple methods of factorizing. See how many you can get completed and upload a photo of your work. Let me know if you need any help with any of these questions or if you'd like some more examples. I'm always happy to do that for you. Thank you very much if you watched this. I'll see you in the next lesson. Bye for now.